Well, thanks very much. I'm proud to live in a place that I can talk about this openly. And I'm really proud you let me go early tonight so that my little children could come and see me. They never know what Mommy does all the time, so they'll probably never come back now. Okay. But I'd like to give you a little overview. I teach environmental planning, mostly to graduate students in the planning school. And so I want to solve problems and do things a little bit better. And recently, let's see if I can make this work. Okay, we won't stay too long on this slide, but as we know, if we didn't have this insulating blanket around our Earth, which is out about 7 miles out, just past the troposphere, we would have a situation where our Earth would be about minus 60 degrees Fahrenheit. That's what climatologists, geologists tell me. Not a very inhabitable space. But as a result of this blanket that we have, which is really made up of heat-trapping gases, we're able to have this comfortable environment that we know. Well, the problem is we have too many gases lately, and the blanket's getting a little too thick, and it's getting a little too hot in here. So what's the relationship between climate and energy? Well, when the Industrial Revolution started, we had about, they say, 270 million parts per million in our atmosphere, in that blanket. And as a result of using fossil fuel, it really has increased over time. If you look at this graph, 87% of the U.S. greenhouse gas emissions come from energy production. So there's no denying that the way we have fueled our economy, our growth, has resulted in this. And one of the things is, as many of you know, there's multiple gases in that blanket. Why do we talk so much about carbon dioxide? Well, the reason we talk about it is it constitutes 85% of the changes that have been happening. Okay, so let's talk about what it means in this place. And so about 2 years ago, I started working with climate scientists. And I think my biggest skill in life, I learned early, is to just keep asking questions and saying why and what does it mean. And so when they keep saying things to me that I have no idea, I just keep asking. And so I'm going to tell you in the way that I understand it. Okay, so what's going to happen here? Well, we know that we're going to have some rising temperatures in this area. And if you look at the literature, right now it says it's going to increase in temperatures on average 3 to 17 degrees Fahrenheit. That's a little bit higher. If we look at the global averages, they're 2 to 11 degrees Fahrenheit. Okay, well, what does that mean for us? So one of the things it means the extension of the growing season. Many of you have probably noticed in the last 30 years, spring comes 10 to 14 days earlier here. Now, as a Canadian, I'm a little bit excited about that. But you know what? There's some downsides. Okay. We see some shifting plant zones, and we see more of those darn invasive plants, which I spend a lot of my summer energy on trying to get rid of. Another thing we're going to be noticing, decreased lake ice, decreased snow cover, increased ice storms, not so good, more extreme heat events, and increased cooling demand from electricity. Let's just talk about that last one. So I've told you it's going to get a little bit warmer here in the winter. But what's going to happen is it's going to get a little hotter here in the summer. And unfortunately, there isn't an equal relationship with the sources of energy that we use for those two things. Primarily, this graph shows you in the United States what is the source of electricity in this country. And it's actually higher here, but you can see half of it in the United States is coal-based. And so one of the challenges we're going to have is that as we try to mitigate the heat, we're going to probably use HVAC, heating, ventilation, air conditioning systems, and that's going to demand more electricity. So that's not so good if we remember what contributes to that blanket. Okay, what else is going to happen here? Now, this is the one that really I think we're more concerned about, the changes in precipitation. And so we're going to see increased storm intensities, increased flooding, stormwater volumes are going to be up. We're going to have faster rains, flashier floods. Stream flow patterns are going to change slightly. We're going to see increases in water pollution. And in our part of the country, that's important because we have a lot of combined stormwater sewer systems. And so that means when we get a lot of rain, often the facilities are overflooded and we actually have direct release of effluent into the receiving water. So not a desirable thing. Next, we're also going to see decreased summer rainfall. and there's infrastructure implications. Okay, so those are the general things. Now I'm going to tell you more specifically. Okay, so again, asking all these questions, myself and some students in this room and a climate scientist decided that we wanted to understand exactly what was going to happen here, or what best we could know. So we selected 3 places: Marquette, Michigan, who are some of the nicest people on God's planet, almost as nice as Ann Arbor, and Detroit, Michigan, and Buffalo. And we strategically selected those based on where they were with the prevailing winds and the relationship to the lakes and a few other characteristics. And we ran some different models. Now, again, I know people find models very confusing. And when I would talk to my friends, the climate scientists, they'd tell me, well, you know, it depends on which model you use. And I said, well, I want to use all the models. Just show me all. Okay, well, geez, nobody had ever asked for that before. Okay, I guess we could do that. And the university computing system was slowed for several months. You don't know this, but it was true. You couldn't get your emails quickly because my student Evan was running all these models. But what these show is this is what's supposed to happen between 2041 and 2070 for temperatures. On the left side, winter temperatures, average, and on the right side are summer temperatures. Notice that this is in Celsius, I'm sorry. And so remember, Celsius, what it's like almost twice as much as in Fahrenheit. If you can see, at the bottom, there's these different kinds of models. There are global circulation models, there's statistically downscaled models, and there's dynamically downscaled models. And I'm sure all of you pray that I will not explain the differences between all those. They do mean very specific things, and they produce slightly different outcomes, but the critical thing to know is if you look at this, you can see Marquette, Detroit, Buffalo, and then the region, the Great Lakes region. And if you look in the winter, and if you just look across the models to get a sense, what are all the different models saying? Well, they're saying that in winter, our temperature should be around 2 to 2.5 degrees Celsius, 5-6 degrees Fahrenheit warmer. What does that mean in summer? So when we look on the other side, we see again Detroit as a surrogate for Ann Arbor there. We're seeing again a little bit warmer. There, we're ranging from almost 3.5 to about 2.25. So somewhere in between there, we think summer average temperatures are going to increase. So some of you might have seen these maps. They kind of frighten me a little bit because, again, I worry about those darn invasive plants. But alas, again, some of the challenges are the scenarios. In this case, there's a lower emission scenario, which means that our conditions will be maybe like the southern part of Illinois. And then there's a higher emissions scenario, which means, boy, we're like the north of Texas. Now, that's at the end of the century. But it's a little bit frightening. But let's come back and look at precipitation, the one I told you that I think really matters in our part of the world. Okay, so in this case, on the left again, we've got winter precipitation. Some of us call it snow sometimes. And on the right is summer. And if you look at our models here again, now this different than the degrees, this is percent, okay? This is the percent of change. We're going to see, if we look at Detroit, that the percent of change there across these different models, we're looking at between 8 and 16% increase in winter precipitation. But one of the challenges is going to be we're going to have warmer temperatures, so there's going to be a lot more freezing and thawing, okay, that go on. So a little bit more there, but let's go over to the other side, which is a little bit more discouraging. If you look at Detroit, we're actually seeing a decrease between 2.5% and about 5% in summer. We're going to have some very dry summer circumstances. So again, we are so fortunate not to be in the Southwest right now talking about this, but we are going to have situations where things get really brown and really dry in our summers. So, Larissa, you're so smart. Well, actually, I never say that, but Larissa, what would you do? These are the things I think we need to do, and I think I'm really happy when I came to the rehearsal the other day. All these other people who are pretty smart about this said all the same sort of things, so I think we're getting somewhere. So, first of all, one thing we have to do is absolutely prioritize energy efficiency. We've got to use the energy we have right now very well. Another thing is we've got to stop building in the floodplain. I'm really happy Ann Arbor right now is taking a look at its floodplain. It's asked FEMA to remap it, and so we've got to really be watchful of that. We're going to have more flooding conditions, so this is of increasing concern for us. Infrastructure planning. We've got to think about long-term resilience in these situations. What we build today will be in place in that 100 years ahead, hopefully, when those maps are different. And one of the big things, I don't know if Janice Bobrin's here, but this is a little plug for Janice, we need to have more pervious surfaces everywhere, so handling stormwater on site is key. Another is we need to revise our building codes. The way that building codes are set up right now is this TMY, typical meteorological year. And that is usually based on information from the 1970s that says what they think the climate will be. And we use it to size systems and to estimate things. And so we have to go back and take a look at those expectations with the new information that we have. And we really need to stress passive strategies. Some of my dear friends in public health think our answer is to install air conditioning everywhere, but we can't do that because we'll blow the grid. But we don't want to. We really want to be very thoughtful about incorporating passive strategies. We need to think about energy diversification and renewables. How do we increase those, as the mayor talked about? Our interest is there. Where is the source? And then finally, comes back to this. We need to reduce vehicle miles, and that means more of these difficult conversations about density. So I'll just end there, and I just worked with some students for the U.S. Green Building Council, and they're going to look at how they incorporate LEED climate adaptation strategies into green building practices. If you'd like this, it's available on the web, and we would be delighted if anyone would read it. So thanks.